Okay, you can see it's working there. It's dim. I gotta try to make it brighter somehow. That's a good one. Okay, so today we're going to be showing how to make this homemade cathode ray tube with primitive materials. I'm talking Stone Age stuff here. So I hope you enjoy. Don't know if it will be successful or not, but hopefully we'll find out. Okay, so I know this will hurt watch time statistics, but I have to actually explain all of the stuff I have to make for this. So here's a basic diagram of all the parts that go into making this CRT right here. You have the main envelope right here, which is made out of just a single piece of glass. Then you have the tube for your anode connection and your evacuation stem, which is made out of smaller diameter tubing. Then you have your anode right here, which is made out of aluminum with copper wire wrapped around it, going outside to make sort of like a spring contact against the anode connection. You can see that right there, how that works. Then you have a titanium getter right here that just allows you to remove some residual gas in the tube. Then you have the support rod for the anode, which is that glass tube right there. Then you have the stem, which, like, you can see one right here. I use a little bit thicker glass for this stem because it's going to have 3 electrodes instead of 2. And here you have your filament and your grid to control the emission of electrons. And just as a reviewer for how seals and Pyrex work, the only material I have that will readily stick to Pyrex is tungsten. And you can't really directly weld the tungsten unless you use nickel. So what you do is I have a copper wire on the outside, piece of nickel sleeving that goes on top and gets welded. Then I have the piece of tungsten wire that makes the seal. Then I have another piece of nickel, and then I have a piece of steel that I use for the connection inside the tube. So you can sort of see that there, right here. So you can see the nickel sleeving on top, the tungsten, and then the steel right there. Okay, so I think that's enough information, and I think we can start with the glasswork now. So I'm going to start out by making the base stem, the leading wires for that, and we need 3 wires. So I have this plus 1, and I have a little bit of nickel down there. And I'm just going to weld this down here just so it's not moving around while we're trying to work on the top. That's a good weld. I used to use the cathodes out of old vacuum tubes to use as the tungsten tube to go over the top, but I've discovered something more effective. What I do is I have this thin nickel sheet, and I just cut thin strips of it, and I wrap it around the wire and crimp it, and that tends to make just as good as weld. Then what you do is you just bend this around the end of the copper. And crimp it. Then I can weld that and then cut that excess off. So now we have nickel welded onto the end of those copper wires. Now I'm going to straighten some tungsten wire. Impossible to do any other way. Now what you gotta do is you gotta take your tungsten wire and you gotta polish it to mirror finish. Whatever the heck that means. That should be good enough. Now I'm going to weld the tungsten onto there. Now take your dull para cutters. Don't use your good cutters. Give yourself a nice, generous piece of tungsten to work with. Okay, so now you're going to want to take a paper clip get that piece. And we're going to spot weld a third piece in the middle. See where I'm going with this? Now for welding steel, you need to have a very, very short weld duration. Otherwise you'll burn right through it. Oh, that was a bit too much still. Okay, so that actually didn't turn out too bad. Now, again, using your dull pliers, do this. Dull dikes, do this. So now we have that. We gotta heat it up in the fire to get rid of the zinc. Hold your breath while doing this. Okay, so now just hold this and sand it until you get all that oxide off. I've had mixed results with welding tungsten directly on steel. It seems to work sometimes, and I might just be lazy today and just crimp this and weld it. Okay, you get the idea. I'm going to do this off screen. This is another delicate series of welds, so I'm sorry if you can't see, but I really need to pay attention for this. I have to have the welder set to a very short duration. Okay, so you see that? Now we have to try to get that into a flare. Gonna be tough. Now we get into some actual glass work. We're gonna make the flare. I just cut this piece of glass using a scoring tool. That's all you need for the diameter tubing I'm using. Okay, so to prepare the flare, we need to bend the end to make it wider to accept the wires, but not too wide that it can't fit in the tubing. So we have to be, it's a balancing act. So for that we use this flare holder. Piece of steel, just bent with notches cut in the end. Holes for wires to pass through, and then just these two standoffs to hold. That holds it just like that. Okay, so now we gotta treat the tungsten to prepare it to seal inside the glass. So I have a bit of an odd way of preparing the tungsten. What I first do is I heat it up in the flame, and then I clean it off with flux remover, ethyl acetate, and then I just heat it up again just to burn off the solvent. And I have found for some reason that solvent treatment really makes the seals work better for some strange reason. Okay, so you're not going to be able to see this, but you see that white stuff on there? That's no good. That's some sort of foreign oxide, so we have to clean that off with the ethyl acetate. Okay, so now I'm just going to gently heat that with the torch. Now I'm just going to wipe that one more time with a dry Q-tip to get rid of any weak oxide that might be on there, and we'll be ready to seal that in the glass. Okay, so that's going to be what our seal looks like. Just going to put it into the seal holder now. Okay, so let's start to work on this. So what we've done is we've just squished the glass on the parts, but now we're going to heat it up really hot and then make the actual pinch.
Okay, now I'm going to go check and see if the seals are the right color.
Okay, I just wanted to show you guys what the color of a good tungsten to glass seal looks like in my experience. So, in my experience, it's sort of a yellow, goldish brown color. And I think these ones look pretty good. Usually for me, if it's black or if it's kind of sooty looking, usually that means there's some oxide coating on the tungsten that separated from the tungsten during the seal, and that means there's sort of like a crack or a discontinuity between the glass and the tungsten, which could let air seep through. So, at least in my experience, I've never had a seal that looks like that. I've never had it leak through the tungsten. Okay, so now we're going to start work on the envelope. I'm just going to use this piece of glass right here, and I'm going to seal off the end and then blow it out to make our balloon shape or something like that. Okay, so now we need some sort of phosphor to coat the inside of the bulb. And for that, I'm going to use one of these. Now, health and safety warning, danger, glass, mercury, whatever. Do at your own risk. But what we're going to do is we're going to rip the ends caps off this to find the nipple, release the partial vacuum, and then we're going to score the edge of this and crack it to open it up. And it's really hard to know which end will have the seal in it. So just have to sort of guess. Okay, get ready. Okay, that's it. Tube is not under a vacuum anymore, so we can crack this open. Okay, now we're going to gently break this open. That wasn't very gentle. Okay, that didn't go as well as I thought, but that's okay. What we're going to do, we're going to take just a plastic container, fill it with water, and we're just going to wash these pieces with a brush in the water. And I'm just going to repeat that for all the pieces and then move on to the tubular sections. And then we'll be able to collect our phosphor that way. Once you've cleaned off a good few pieces of glass and you think you have enough phosphor, just want to give this a stir and let it settle out for a little bit. It might take 15 minutes or half an hour for all the phosphor to settle out because it's very, very fine particulates. Okay, so the liquid has mostly settled now, and I'm going to very carefully suck the remaining liquid on top off and put it into a different container. Here's our phosphor. You really do not need that much to coat a tube. This will be more than enough for several tubes to make. Enough to make several tubes. Okay, so now what we're going to do is we're going to coat the inside of this with phosphor. So what we're going to do is we're going to take the very concentrated phosphor and water mix, shake it up so it's a very concentrated slurry, and just going to pour the tiniest drop inside. Now what we have to do is we have to evaporate the water. And I'm not going to show this step, but what we're going to do is we're going to heat this very gently with the torch while moving this around until all the water is evaporated. Okay, so now we're going to make the tube for the anode connection here. We're going to make a feed through just like we did with the other one. Yeah, it looks great. Seal it in some glass now. Okay, now we're ready to seal this into the glass. We're going to attach the anode connection to the new tube now. I recovered this from the previous one and flared it a little bit. The wire broke off, but there's enough there that I can solder something to it. And I'm going to blow a hole in the new one and try to seal it on. And I'm going to try to do it without being distracted by the camera. Okay. Now I'm going to pray that that doesn't crack, because there's a sharp angle right there. Sharp angles are not what you want in glass blowing at all, but I'm going to hope that that doesn't crack. Okay, so I'm going to flare this piece of tubing here for the evacuation stem on the tube. Okay, that should be good. Okay, so I'm going to attempt to attach this to this, but first we need to close off the end of this. Just let that cool for a little bit. Okay, I think that one turned out good. That's a good seal right there. Okay, so now we're going to make the electron gun assembly on here. And the first thing we're going to have to do is clip the wires. This is also one of the scarier parts of this, because if we crack the glass, it's all over. So we gotta clamp these very hard. Okay. That's the most hazardous part. Once they're all separated, you're not putting stress between any of them, and you're not safe, but you're a lot less likely to crack it than you were before.
going to bend this one out of the way. Okay, so what we're going to do is we're going to put the filament between these two pins, and then from here we're going to have the grid spot welded onto there and come to the top right there. Okay, so for the filament we're going to use 0.08 millimeter tungsten wire, and we're going to wind it around the lead of this resistor right here, and maybe do about 6 or 7 turns. Okay, that's going to be our filament. Just going to try weld it on there, see if it works. Okay, I'm going to put a little piece of metal on top of where it's welded. Okay, that's all done. Just have to make the little loop that goes on top now. Okay, for the grid I'm just going to use this little piece of nickel wire. And I'm just going to bend that into a loop. It goes on top of there, and bend it over and weld it there. Okay, that's going to be it right there. Fits inside the tube. Just have to figure out how to best weld it right there. Okay, so this is going to go right up there like that. Now I just have to weld it. Okay, so we need to expand this piece of tubing to be able to fit over this just a little, and then we're going to heat it up and melt it into the seal. Okay, so that's how it's going to work. We're going to heat that up and seal that on there. So we're going to test this with the high voltage, but we're also going to have to go through several iterations of heating this up and bending this back and forth so that it is in the center of this right here, because it's probably tilted in one direction or the other right now. Okay, so now we're going to test to see if this made a good seal around here or not. Okay, nope, we got a hole right there. Okay, so I'm going to heat that up and see if I can fix that. Okay, so I just heat this up in the flame a little bit more and squeezed it a tiny bit, and I'm going to see now if that's leak-proof. Okay, that looks good. So now we can move on. Okay, so that's how it's going to fit together. Okay, so for the anode, we're going to use this piece of aluminum here. And we're just going to cut it in such a shape that it can fit on here. And we can bend tabs over the side and wrap wire so we can make it secure. Okay, so this is the shape I've come up with. These two tabs will bend around the side of the tube, and then these little tabs will bend around the side right there, just to give some more support and to keep it from falling off one side or the other. So I'm going to give a trial fit and see if I can bend this and put it on there. Okay, so this is what the finished anode cap looks like. So now I'm going to punch the hole in the top. Just going to go very slowly. I might just go with that. Yeah, I think I'm going to go with that. Hopefully that will reduce the spot size. I'm just going to wrap this copper wire around here and then make a tail for it that will go down the anode connection. Okay, so for the getter, we're going to use this titanium wire, and I'm just going to bend this into a loop and spot weld it, making sure that the loop is small enough that it can fit inside the glass. You need a very short weld duration to weld titanium. It's very resistive. There we go. Now I just gotta bend this down without it breaking. Okay, so we need some way to mount the getter onto the anode right here. And what we're going to do is we're going to make a ring out of nickel with a little tab coming off
and slide it over the outer rim of the anode, and that will support our getter. So here I have 2 strips of nickel. I'm just going to weld them and form them into a loop and draw them around the outer perimeter of the anode and crimp them into place. Okay, so this looks good, so I'm going to heat up the getter to drive off the zinc and then spot weld it on there. Okay, that's the electron gun finished. Okay, so now that is pretty much all done. I just have to clean it off, and then we can install it inside the tube. Okay, so to clean, I'm just going to spray it off with some flux remover. Hopefully that'll take the oils off. Then I'm going to move this out of the way. I'm just going to gently heat this. Okay, so hopefully that removed the majority of the contaminants on the surface of the glass. So now this is going to be tough. We gotta try to fit this up inside here, and it's pretty tight fitting, so it's going to be a challenge. Okay, I think that's going to be okay. You can see you can't see. I wish this piece of copper wire, I wish I would have bent it a little more so it's make contact over a larger area, but I think that should be okay. So I think the last thing to do is to seal this now. Gonna have to cut this end off and polish it, and then seal it down here. Okay, so I have the tube clamped in this vise, and the problem is you're exactly where I need to be, so I'm just gonna do my best.
that should be our finished tube. Now just have to hook it up and let it pump. Okay, so this pump is due for a rebuild, but I'm just going to try to get one last run out of it. Okay, so you can see that there's some water vapor in the tube right now. So hopefully when I connect the pump, you'll see that disappear. Okay, now all that I'm going to do is I'm just going to let this sit for a little bit. I'll heat it up. Okay, so I'll let that cool and then I will check for leaks. Okay, so I have the high voltage power supply hooked up and I'm just going to wave the high voltage lead. So we got spark. I'm not getting any leaks going to any of the seals right now. There's little sparks like that right now because it's not completely pumped down, but as it pumps, those should go away and it should stop doing that. Okay, so I'm experimenting with it and trying to get it to work on the pump. That's the first sign of life. Okay, I'm gonna let it keep pumping now. I'm going to try to seal it off. Okay, so this is the getter flasher. It's basically just a modified ZVS circuit that's designed to work at a higher frequency. And it has a 12-volt supply for the gates. That's very important. You blow a lot of MOSFETs without having that. And it's really just barely enough power to give me what I need to do. But I haven't gotten around to build a better one yet. Okay, let's show you what a getter flash looks like on these tubes. Come on. It's really not that bright in real life. The camera is just more sensitive to the infrared light this gives off. Okay, that should be good enough.
Okay, so this is the best I've gotten it to work so far. I just hooked it up and let it sit for a little bit, and it was acting kind of erratic. And then I flashed the getter, and it seems like it liked that, and it seems like it's acting normally now. Okay, so it seems to have calmed down mostly. It's still doing that flickering thing. I wonder if the tube is oscillating somewhat. But at least it's making a dot. I just hope I can get it to run steady so that I can do good deflection on it, because you really need a steady dot. It's no good if it's moving back and forth. Nope, I lost it. This thing has to be oscillating. Okay, so I think it's ready to try the deflection with the homemade CRT now. It's still acting sort of erratic, but I think it could be stable enough just to get like 30 seconds of video or something. So I still have the tube tester that powers the filament and the grid voltage. Have the high voltage power supply giving the anode voltage. And we have this power supply right here, which is powering the sawtooth wave generator. And here we have the deflection coils right here. You can see the one on the bottom is for the horizontal deflection, and the one on the side is for the vertical deflection. This gets the sawtooth wave through this capacitor right here from this circuit. And I have this just hooked up to the variac so I can apply a varying voltage to it. So let's hook it up and see if we can try to get it to work. Okay, you can see it's working there. It's dim. I gotta try to make it brighter somehow. That's a good one. So as you can see, it looks like the homemade CRT was a pretty much complete success. This is the sharpest dot I've been able to get so far. It is still erratic, as you can see. And it is more dim than I would like, but that's the best I can get it right now. Seems like the pressure in the tube is fluctuating, which is causing the characteristics of the electron gun to change.
right there. Perfect, perfect. Sorry about the glare from the filament. Not much I can do about that. But there you can see the sine wave. So I have a sawtooth wave going into the horizontal axis, and then a sine wave going into the vertical axis, just 60 hertz from my variac into these two relay coils right here. And that is giving me that pattern. Yeah, that filament really does outshine everything. Maybe I can figure out a way to cover that up. But that seems to be a complete success. Thank you all very much for watching.